diagram, so I'll have to review this. But let's just at least get it out for you guys. So let's start again. Chris has 4 pairs of socks in a drawer, each pair of a different color. He selects socks one at a time and at random from the drawer. The probability that he does not have a matching pair after selecting the second sock is, so we've got a sock, the first you could have had, so this is already done, right? So if it's matching, it would have been 1 out of 7. One particular sock left out of 7 socks left. Not matching would have been 6 out of 7. In your second one, if it was not matching, then again, for it to still not be matching, there's 4 socks left out of 6 socks altogether. If it was matching, then that would be 2 out of 6. So either the green one here or the blue one here out of the 6 remaining socks. Does this tree diagram make a little bit more sense than maybe what I was doing?
Yeah.
And then, I don't know, this first one's easy, but find the probability that he does not have a matching pair after selecting the third sock. For him to not have a matching pair, you would just go not having in the second one and not having in the third one. So 6 out of 7 times 4 out of 6. And then what is the probability that the first 3 socks include a matching pair? For the 3 socks that have a matching pair, will be 1 out of 7 plus not, and then 2 out of 6. So for this one here, it'll be either having a matching pair at the beginning plus 6 out of 7 times 2 out of 6. So I guess seeing a tree diagram is easy, but it's just not what I would have done. So I've got to really go back and think about this and see how I would have done this, because I don't think I would have done a tree diagram, but I know 100% I wouldn't have done a tree diagram. But I've got to think about what I'm clearly missing with that. But okay, that's fine. I think when you see a tree diagram like that, you can see the solution. It makes sense, but you got to be realistic. It's not the way I would have done it. So I've got to think about the way I would like you guys to learn it as well. But anyways, at least you got that solution out. Let's have a look at another one then. Maybe we'll look at this. Let's see if we can get this one out. The spinner shown above is used in a game. Once spun, it is equally likely to stop at any of the letters A, E, I, O, U. If the spinner is spun twice, find the probability that it stops on the same letter twice. Well, that would just be 1 out of 5. 1 out of 5 times 1 out of 5. So this spin on I will be 1 out of 5 times 1 out of 5, and then that can occur, or E, or this, times 5. So 1 out of 5, so like let's just say if it was on I, for it to land on I twice, it'll be 1 out of 5 times 1 out of 5, right? Because I and then I again. But then that could have occurred any 5 times. It could have been on O, U, A, and E. So the answer just becomes 1 out of 5. Now, I could be wrong again, so let's have a look. Ah, finally, something we're not doing wrong. So there it is, 1 out of 25, and then it could have been any of them. It could have been A, A, E, E, I, O, O, U, U. So technically times it by 5, which is 1 out of 5. We get that? How many times must a spinner be spun for it to be 99% certain that it will stop on the letter E at least once? How many times must the spinner be spun for it to be a 99% certain chance that it will stop on the letter E at least once? Oof. That it will stop on the letter E at least once. So how many times? So if you do this first spin, it could have been, let's say it was E. That's a 1 out of 5 if it was E. If it wasn't, then it was going to be I, let's just say, which is 1 out of 5. Then it could have been I again, which is 1 out of 5. Then it could have been I again, which is 1 out of 5. It could have just kept doing that, right? So what's the probability of landing on I every single time? It would be 1 out of 5 to the power of, let's say, n. For you to get letter E at least once, it's the probability of not getting letter E. Not letter E is the probability of at least once. So probability of not letter E is 1 minus not letter E. So these 4 letters. 4 out of 5. 1 minus 4 out of 5. So you just keep getting these ones. Not letter E is 1 minus probability of not letter E. Sorry. What am I saying? Probability of at least once is equal to 1 minus probability of no E. That means 1 minus 4 over 5, which is what I had written, which is 1 out of 5. And then what you want to do is get that with a 99% certainty. So 0.99 needs to equal to 1 out of 5 to the power of n. Is that what it's saying? Alright, let me see. I got my answer as no, that doesn't make sense because it doesn't add up. 0.006 times. How many times must the spinner be spun for it to be 99% certain that it will stop on the letter E at least once? So at least once means 1 minus probability of no E. Not getting E. 1 minus 4 over 5 to the power of n. So you just repeatedly get it. Repeatedly. This needs to equal to 0.99. This needs to equal to 0.99. Yeah. Because that's to the power of n. That needs to occur. So then that becomes negative 4 over 5 to the n equals negative 0.99. Sorry, 0.99 minus 1 divided by negative 1 log that divided by log of 4 over 5. I'm just doing everything in my calculator before I, yep, which means n will be 21 times or something. Let me see. Yeah, 21 times. All right. Wow. We're doing some serious questions. Okay. All right. So you ready? How many times must the spinner be spun for it to be 99% certain that it will stop on the letter E at least once? Okay. For it to be at least once, the probability of at least once is the same as 1 minus the probability of not getting any E's. Do we agree with that first step, that first line? It's just like you saying probability of at least one head is equal to 1 minus the probability of no heads, which is tails. And that would give you at least one head. Or all tails, sorry. Yeah, that would at least get you one head. Do we get that logic?
Yeah.
Okay, so then from that, I went 1 minus the probability of no E is obviously, there's 4 letters. So 4 out of 5. And then it just keeps repeating because you keep not getting E's. So to the power of n. You just keep not getting E's. So 4 over 5 times 4 over 5, so 4 over 5 times 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 4 over 5, and so on. So 1 minus 4 over 5 times 4 over 5 times 4 over 5 must eventually become with a 99% chance of getting at least one E. And that's what you're trying to work out. And obviously, what we've learned in logs, the only way you can work out n is by using logs. So your first step after this is to subtract 1. So you get negative 4 over 5 to the n equals negative 0.01. You would divide by the negative. You would log both sides. So if you log both sides, they'll look like this. You bring the n down, and you're left with log 4 over 5 equals log 0.01. You divide it. And then it should give you 20 point something, like 6 or whatever, which means you've got to round up to 21. So n equals 21. If you spin it 21 times, you have a 99% chance that you'll at least get one E. But, I mean, see, the harder ones I can do. It's those simpler ones that just, I don't know why I can't. My head just doesn't accept those simple questions. But anyways, what do you guys reckon? I think the most important bit is just this first step. If you can understand how to get this first line out, or how I got that first line out, then the rest is just looks like what you've been doing in logs. Please ask me any questions or any steps you want me to clarify. Any questions?